I've been wearing a few different hats as a software developer. Right now, I do iOS development part-time for my own company as a consultant, building my own apps, and also working on other folks' apps. I also have a kind of a day job or a higher-paying job, maybe, that where I do server-side development in Java and Scala and web development for the client of that server. And so I've built APIs and over the years, and I've consumed them both as an iOS developer and as a web developer. So I wanted to kind of talk, before I go on, this picture is a little bit personal thing about me. My favorite band is Pink Floyd. These are not the designers of REST, in case you were wondering. This is actually an 80s rock band from the 70s, but you might see references to Pink Floyd in this talk. So,
are they comfortably numb?
I believe so. And anybody who saw the Harvest Moon lunar eclipse, you saw the dark side of the moon. I sort of came up with this talk because there's a lot of what we do is, as app developers, is interacting with web APIs, and I think there's been a lot of change over the past few years in web APIs, and I feel like there's some things that we can do as app developers to create a conversation with the people who build the web APIs. We're not always building the APIs; we're just consuming them, but there's things that they can do to make our lives easier, and I want them to start a conversation or give us some more ability to talk to them, be like, hey, don't do it that way, because sometimes you don't know, or they don't know exactly what the best practices are or what's going to make an iOS developer's life easier or a web developer's life easier. So I'm going to talk a little bit about the API design, something called HATE-OS, or hypertext as the engine of application state, which is a mouthful, but it's important. I'll talk a little bit about caching, and then hopefully if people have questions, we can go into sort of a discussion about more specific issues. So the web, the classic kind of web of websites and HTML pages, is built on the REST architectural style. So it's been around since 1995. It was a PhD thesis from a man named Roy Fielding, and it's stood the test of time, right? The internet has scaled to billions of devices and users, and the classic website architecture is what we use today still. Now we're doing a little bit more than websites with apps and with Internet of Things and all that, and so I think there's going to be more need for non-HTML APIs going forward, and non-browser clients going forward. So early on too, there was an attempt to build APIs, non-HTML APIs for applications that became popular for a little while and then died out. Things like XML RPC, SOAP, which I had the unfortunate privilege of working with for a few years before it blew up in our phase 2. Things like Corba, and this was all under the rubric of web services, where people said, you need to make APIs that different machines can talk to and that our applications can talk to. But they all really crashed and burned for various reasons, and none of them, and they all ignored the web architecture, REST architectural style. They're all built on kind of a classic, like, I'm going to make an RPC call. I'm going to make an object that's over there on the network look like it's local to me. So I can, get an object and I can say, get stock quote, or, add, calculate, method.calc 1 + 2, and it looks like a function call in my code, but it's actually going over the wire and doing something. Well, that looks great on a demo, but it doesn't scale. And if the internet had been built if the HTML world had been built like that, we wouldn't be talking. It wouldn't be here. We would be doing something different. So people realized this, and they started saying, well, you know, the web is built on REST. Why aren't we using that in our APIs? And so we started seeing books and subject matter about RESTful web services. And these embrace a uniform interface. And they use different data formats. So, you know, it's not just HTML, it's JSON. You'll notice I put XML up there with fire. You know, XML can crash and burn in that world. Yeah, exactly. And you know, that's another. You know, why did it crash and burn? Well, because like some of those other systems, you know, RPC style systems. So, you know, XML is very. You know, it freaks out if you mistype one character or forget to close a quote or something like that. So, not a very helpful system to build an internet scale application. And you know, language and platform agnostic. So a lot of these old systems had client libraries that you had to find. Like SOAP was always, you know, I gotta get the .NET client library, and it was like 40, you know, DLLs or you know, XML parsers, and oh, and does your XML parser support this feature or that feature? What a disaster. So we've all moved away from all that, thank goodness. And so. We move towards a RESTful API, which means that now we're looking more closely at the resources in the system. So that's the concept is it's representational state transfer. So the important thing is not function names and procedure calls, it's resources. So, you know, an app that has a collection of artists, you know, and what is the resource? So the resource is an artist detail information. So the URLs identify a consistent name scheme for naming these resources. And you can see, so you know, we have a style where you specifically name the artist versus the second style there, this one that comes down, where it's not really, it looks more like a procedure call. And it's got some ugliness in there where it's got servlets. So it's leaking out some implementation detail of the server, which is no good. And it's saying, you know, I want to get something, some information. Here's a parameter called with the artist's name. You know, that's not the good style that we're looking for. And the interesting thing, you know, so leaking out implementation details of the server is not what we want to be doing. When I look at what are the good styles of RESTful API design, you know, I think it's important that these resources stand on their own. So when you look at that URL, you can see exactly what we're trying to get to there. When we want to use query string arguments, we want to use that for optional, you know, description things like you know, I want to make a you know, I can get the list of artists here, but maybe I want to limit it. But I don't have to limit it. You know, I can still get something back. So, you know, in these older styles, the query string arguments were almost fundamentally important. But really, I think they should be for optional things. And that way, you know, for whatever reason, you might not, you know, your URLs will always return something. Another style that we're starting to see now too, which is interesting and I think is really useful, is what we call matrix parameters, which are parameters that are embedded in the path segment of the URL. And this is really, really useful because it is descriptive, but it also allows that to be unambiguous. So if it's a query string argument, right, the query string argument typically is going to apply to the thing at the end, but in theory it could apply, it could be descriptive about any part of the path. Whereas here, we know that the latitude and longitude parameters here are specifically about the map, and it's not, you know, my friends don't have latitude and longitudes. So this is a great technique to use when you want to build resources that need parameterization, especially that's required parameterization, right? Like a map without latitude and longitude may not be useful. So that's a style you can tell people, you know, use this style of URL and let the query string apply to, you know, optional things. By the way, you know, if anybody has any questions while I'm going, raise your hand. Yes.
So that style you just showed,
Yeah.
how do you? I mean, what is that? How do you like get that when you're reading that URL?
On the server side, you mean, or
Sure.
Yeah. Yeah, you can. There's most frameworks, at least the ones I've worked with on the Java side, support this concept directly, and they have a scheme where, just like with query string arguments, you could say I have an argument called lat. It's a number, but it's a matrix parameter, not a query argument. And on the client side, you know, you probably don't see too much, you know, the official support for this, but you know, if you build that into a NS URL, you know, it's going to accept it. It's totally valid. Yeah.
Okay. Yeah, and on that, I was thinking the same thing. I guess I'll just come through the path element, right?
Yes.
According to the RFC.
According to the RFC.
All those are valid characters.
Yep. Semicolon and a comma is the other one you'll see used as a limit sometimes. If you don't need to name the parameter, so like maybe with map, you just want to do, it's always latitude, longitude, you might just do map, comma, 50, comma, 20. And then it gets a little bit more compacted, but it's all valid. Yes.
You might cover this later. The way I would do that would be just the static path /square post a request and include those parameters and spot it.
We don't want to use post though, because post doesn't get cached. And typically you're going to want, if you're getting information, you want to use get. And that's the only time. I'll talk a little bit about that actually in the next slide. The post is really ideally used for a creation kind of process, or a, you know, kick off something, some action on the server. When you're retrieving information, get is really what you want to use, because get has a couple of important properties. Caching is one really important property. When you're getting, you can, you know, the server can tell you, hey, you know, you can keep this resource for a certain amount of time. I'll talk about it a little bit later. And it's what they call one of the safe methods, right? If you can get something over and over, and it doesn't cause any harm. Posting is not that way, and I'll talk a little bit about that in a moment. But these are the sort of kind of a classic RESTful API that's got a collection resource and then detailed resources for each, you know, for each thing in the collection. Maps these methods to, you know, for these different operations. So getting is always retrieving either the list of things or a single object. Posting is going to create, posting of the collection is going to create something. Putting to it the detail is going to update that object, whatever that is, and deleting is going to delete that particular thing. So, you know, that's pretty straightforward, right? But what about stuff that's not that doesn't map to a straight collection? And one thing to think about too is that sometimes, you know, a lot of times it's fairly obvious, you know, okay, I have a collection of artists, but maybe there's features I have around artists, like I can tag an artist, or I can make them a favorite, or, you know, I can send them to a friend to, you know, or tell a friend to follow the artist or something. So there's things that don't really map to that kind of basic collection, and what do you do with those? And the thing to think about there is that an action could also be a resource, right? So if I have, you know, this concept of sharing, maybe sharing a document about Pink Floyd with another user, I might, you know, say, you know, like a classic way to do this, and maybe a lot of APIs do this, is that you post that document to some share endpoint. So it kind of looks, it's using a verb, And it looks like an RPC call. It's sort of like there's a function called share, and I pass it some data, and that's going to do something for me. But in a RESTful model, you don't want to necessarily think about it like that, because what you may be better envisioning is there's a resource called the list of shared documents that I have. And so what you're really doing is you're adding a document to the list of shared documents. Or, if I have favorites, I have a list of favorite artists, and I want to put something into the favorite artist list. So a lot of times, the things that we think of as actions or commands may be manipulating things in a certain state. And so you can model that as in a RESTful style that matches this system. This is, I could have a collection of favorite artists or artists I'm sharing with people, or even you could have even a simple collection of actions, right? If you think about maybe you have long-running actions, that you want to monitor, right? So maybe I'm starting a bank transaction or something like that, and it might take a couple of days to get the money in and out. If I have a resource of transactions, I can post to that, and then I can actually get a resource that maybe is a URL to the status of that transaction, so I can monitor it. So even things that we think of as being kind of a command or an RPC, we can model as a resource, and that provides some benefits. Putting or posting, so I kind of touched on this a little earlier. When to use, what do the two of them mean? Because they both are ways to send data up. And as I said earlier, posting is really about creating an object, maybe starting a process. I'm going to post a comment. That's really how you want to think of it. It is not a what we call item. Actually, I'm not really sure how to pronounce that. Some people say idempotent, and some people say I say idempotent. What does this mean? This means that you can do it. You can do something multiple times, and it doesn't have, change the outcome, right? This is important for a network application, right? Because if I have a weak network connection or a spotty network connection, I might need to retry things, right? So if I have an operation that's idempotent, I know I can retry it over and over again, and it's not going to cause a problem, right? So if I put something and I don't hear back, I could put it again. Or if the network connection drops and comes back, I could put it again. And it's okay if I put it again. So if your server side is correct, it's okay if you do it again, right? So if my resource for favoriting an artist, right? If I favorite an artist, if I favorite the artist again, it doesn't cause a problem, right? That artist is still my favorite. So if I was going to implement a REST API to favorite something, I could use put so that, if the app, the user hits the little heart button and I say favorite this artist, and, for some reason their connection drops, something when reachability tells me I've come back, I can put it again, just in case. Maybe I didn't get a response back. I'll put it again, because it doesn't hurt to keep saying that they're a favorite, right? And that's a very valuable, that's a fundamental thing with the REST style, that things like an RPC didn't really have a concept of. You don't really have a concept when you make a function call of like, do it again, because it's safe that you do multiple times. So you can talk to your service team about, when to use these two, because the put feature is really important and maybe something that you can take advantage of. And make sure that on the server side, they don't give you an error back if you favorite something that's already a favorite, right? Because that's sort of unhelpful. Okay, so another nice feature of REST is that you can expose multiple resources in multiple formats, right? So JSON, but maybe HTML, maybe XML, if you're still stuck with that. And the client can ask there's a method for what they call content negotiation, which is, I want to ask for something in a certain format, and you can use an step header for that. A lot of times, if the API is done well, you'll see the file extension be used as a way to do that, just so that when you're doing like a curl operation on a command line, or if you go into a browser, you can just do type.json or .html, and you get different, you can kind of ask for that specifically. So that's a very useful stylistic thing. And being able to get an HTML representation of something is pretty useful, even for an API developer, because it can give you potentially a way to interact with the thing in a more friendly way than JSON. What I would also recommend too is that the server returns in your JSON format, use a root envelope object of some kind. So don't just return arrays of data or just pure data. Put up wrapper objects that says maybe a timestamp, what user requested it. You could have the count of things in the result set or something like that. This stuff is useful because you may want to cache that information, use it later. You may want to save it in the app and be able to use it later and know where it came from, how old it is, things like that. Another thing that's important is that errors can also have responses. So if you get something and it's not found and you get a 404 back, a lot of times the servers, if they don't do a good job, they'll just return like the HTML page from the server that says, which looks great in the browser, but is really unhelpful for an iOS app. There's no reason to do that. There's nothing in the HTTP spec that says, 400 errors have to be HTML. So make sure that they use the same JSON format envelope to return, an error code, maybe a message to display to the client. Make sure that when you're writing your NSURL section code or whatever, that you're deserializing the response, even if it's a failure, right? Don't just say, oh, it's a 400, so I'm going to do an NS error or throw an exception or something like that. Deserialize anyway, because that's, there may be important information in there about the error, and there should be. There's also some interesting specs, which I go into a little bit later, where people have proposed kind of a more formalized way to structure your JSON, so that you can kind of provide this kind of standard envelope and standard, just like HTML provides a standard structure for data. There's some emerging JSON standards for doing that because, the Wild West does the benefits. And so if you can provide some structure and consistency, that makes the client developers' life easier too. All right. So the JSON is part of the API, right? I mean, that's actually a pretty important part of the API because it really describes what you're passing around in a RESTful architecture is JSON data, it's representations. So there are only 4 verbs. It's get, put, post, and delete for the most part. So the data that you're passing around is your part of your API, it's a fundamental part of the API. And watching, a lot of what is going to change over time as your apps change and evolve is really the JSON payloads, not necessarily the URLs of the server or what the verbs are. And I made a rookie mistake when I first started up my first iOS app, where with the JSON payload, I was using Objective-C classes, right, that had all the properties of my JSON models, and I was deserializing that with NS-JSON serialization, and then I made the mistake of using set values for keys with dictionary to populate my models with the dictionary, because the names matched up and everything. The problem with that is that a new version of the server added a new property for a new feature, and of course, if you pass in a dictionary with unknown properties for that, it crashes. You get the unknown property exception. So you can create a pretty tight coupling between your server version and your app version with very specific models. And I'm certainly not saying don't use model classes and don't use specific Objective-C or Swift structs, but just be careful about the deserialization, making sure that it's always being driven by your struct or your class definition. That's why I was asking about the reflection in Swift, because you really want to be able to say, what are the properties of this struct, and I'll take those out of the dictionary rather than having the dictionary drive the deserialization. Okay, so hypertext. One of the things I think most web APIs don't do very well is hypertext links. So what do I mean by that? Is that in the HTML world, when you go to a website, how do you interact with the website by clicking links, going from page to page? Yes?
So do they hate it? Is that why it's a hate OS?
Yeah, maybe the server got hated. Yeah, exactly. I think that's a thing that we miss in the usability of our web APIs. Because if you think about it, you get just a document back from an API. It doesn't really, just a JSON payload, it doesn't give you any information about what you can do with it. Right? It gives you back some properties, but if you compare that to, like, if I go to a website, I mean, a good example may be if I see if this is going to work. Yeah, this. And so if I look at, say, if I go to well, let me just, I'll show you here. So I'll pick on Spotify, because I've done some work with this API before. Spotify has a pretty nice set of documentation here. And it has things like, here's the artist collection, you can get an artist, you can see the albums of the artist as a resource, the top tracks, related artists, right? It tells you, okay, it returns, an artist object, right? And so I can look into that, and if I look at the documentation of the artist object, I can see, it's got some followers, and it's got a link to the web API endpoint providing the full details. That's nice, and it's got IDs and images. But it doesn't really give you anything else that you can do with it, right? Like, there's a whole bunch of APIs. What about the related artists? How do I get them? Oh, I have to go back up here and look for this. And what if I want to favorite that or follow that artist? I have this ability to put, and do a follow some artists, but that thing didn't tell me anything about that. And I kind of put it sort of imagine looking at like the documentation for something like, for some kind of object like NSURL session, and then not having any methods. Like, here's the properties of the URL session. And then where do I go to find what you do with it? Oh, you got to go somewhere else to look for that. It doesn't really. And then if you think about like if I went to the page for the artist Pink Floyd in the Spotify app or in the Spotify website, there would probably be links to, there'd be a button to follow the artist. There'd be maybe a link to the related artists. There'd be a link to the album, or the albums, or a link to the albums. So there'd be all these links that I could follow as a user, but nothing for me as a developer. So I think that's where we can do better. And because the state of an application, the state of a website is the HTML pages and all the links between them, right? And so the state of an application is on the server is effectively the JSON that gets returned, and all of the links, all the things that you can do with that JSON. So what I would say is that we want to encourage building the web APIs like almost like building a website, where you could have every API has a root document, and it has like that list of links. Like the links I just saw on that nice HTML page, are not available programmatically, which is weird in a way, because they're there, they're implemented, but I have no way to, I have to go and look it up and figure it out myself as a developer. And that's fine if you're building a one-off app, right? I only need these 3 things, but it's limiting because now I don't know if they add new functionality. I can't really discover that automatically. I have to know to go back and look at the documentation. And if my app wants to know if something can be done or maybe something can no longer be done, it has no way to tell either, right? If a feature gets removed, the app has no way to really tell. So let me go back to that example, and let's look at this. So using the Spotify web API here. So here is the JSON for the artist Pink Floyd from the Spotify API, and you can see that it actually has some links in it, right? It's not like it's totally useless or it totally has no relations. I mean, they put in nice links to all the images. Right, so that image you saw earlier in my talk, I think, is this one right here, and so I can get the graphics, I can see the link itself that I've just used here. It's got a link to the website Spotify to open that artist in a browser, but it doesn't have any of the other. It doesn't have links to their albums. It doesn't have links to how do I follow the artist. It doesn't have anything. So I think this could be better. And what would it look like if we wanted to sort of expand on that? So imagine now the service returned something like this, where those 3 sub-resources we saw in the documentation. Well, the server actually can tell me exactly what the link is, because it knows when I reference this artist with Pink Floyd with this ID. Well, it can tell me exactly what the link is for the albums, and exactly what the links are for the related artists and top track. I don't even have to go look that up in the documentation if I don't want to. And I don't have to build it. If we look at the documentation here, right, it says, it has this little the little ID in parentheses, right? Oh, which ID is that? I mean, there are several. And so I have to go figure that out, and I have to go manipulate the URL programmatically and make sure to put that in the right spot. Yes?
Is there a specification for defining an API like JSON, like you said, like index.json, that your application can consume? Because theoretically, you could just consume that the API by your app, and then your app will know how to build those URLs.
Yeah,
so we're looking to do that or that.
There is a spec called home documents. Or let's see, I don't know if I have it. Let's see. It was done by this guy Mark Nottingham, and let me see. Get lucky here with the JSON home document. So I haven't seen much activity in this, but there is a proposal for doing exactly what you're saying, where kind of like standardizing an index.html for a web API. And as you can see here, it has puts in a lot of detail about what, for a given resource, what methods it allows, what formats it supports. Does it accept byte ranges, things like that. So it really goes into a fair amount of detail, and I haven't, I don't know really what, you see it's dated 2013, I'm not really sure where this is and sort of what kind of document this is, but you can certainly use this as an inspiration for your own APIs.
That's really cool. It's like someone handing you blueprints and
Yeah.
you just automatically being able to be like
Yeah.
a 3D printer or something like that.
Yeah, exactly. And I think, we're not building, our apps are not like a web browser. We're not really necessarily building a generic thing that has to deal with arbitrary websites. So we kind of know, we have a constrained set of functionality that we work with, but this is still useful, I think, because it turns your app into something that, instead of dealing with hard-coded URL strings, you're now dealing with something that maybe is more of a feature-oriented thing, right? So I have an example here of a home document for this little like demo site that I got. Let's see. Right. That's right. Right, so this is pretty simplistic, but just for the sake of this, it has a list of a couple resources, one for login, and one for getting the collection of artists. But the interesting thing I think about this is that, I built an iOS client to consume, to be a front end for this. What I'm going to do is I can immediately fetch. I know this URL I can hard code in my app, right? That's sort of the safe one. But now if I want to do the artist's view controller, I can speak to it in terms of the concept of the lists of artists, and so it's not me hard coding another URL into my view controller somewhere or into some kind of API class. Now I can say, I have a feature that wants to display the list of artists, get it out of there, and this URL now could change. Somebody in the server team could be like, I'm going to put the artists, into a list, a CDN somewhere, because the list of artists is not realistic. The list of artists isn't going to change for a couple of weeks. So we're going to put this huge JSON file over on the CDN and get it off of our server so we don't take the load off of our server. So now all of the iOS apps are going to suddenly be downloading this JSON file from a CDN and saving the bandwidth for the main application, right? But nobody had to push out a new version of the app. Nobody had to change any code because all we're doing is saying, I need the link for artists, and it's still going to be right. So interesting things like that can happen when you get out of the kind of hard coding of URL world. So continuing with this, let's see, pretty good. And as I said here, I don't like building URLs. I'd rather just get a URL out of a JSON property and just call get than have to manipulate it. And then, so what about following? So let's say, okay, I have some links to some other things, but what if I wanted to know how to follow something? So you could have a list of actions, and the actions would tell you kind of what's available, what the API allows you to do with that model, with that artist, or whatever your entity is. So maybe I can follow. Maybe the follow feature is a new feature, and so it would appear and it tells you, what's the action? Well, it's this following URI. What method do I use? I put to it. What do I put to it? I put these two parameters, in whatever format, right? Maybe it's standard URL encoded. I'm following an artist, and here's the ID of the artist. And notice here too that I don't have to actually write any code to do this because it's, I don't have to hard code this logic, right? I can actually build an NSURL session, like category or something like that takes this structure, and I can just give it this piece of JSON and say, do this. And, it can just go and do that. And so now, if the API for the following verb adds a new parameter sometime, I don't have to change my iOS app. I'm just going to get a different piece of JSON. I'm going to give it to my, NSURL session wrapper It's going to add the parameter for me. It's great. So I don't have to, again, I'm not changing any client-side code. I don't have to push out a new version. I think a lot of the times we see APIs, the versioning aspect of APIs is because a lot of stuff logic gets hard-coded and then can't be changed without changing the code. So that's why I think I really like this kind of style, and I've used this with the application that I'm working on today with the Java Scala web application. It does exactly this with commands. So when you do a right-click kind of in the web browser, when you right-click and get the list of commands or something, that's actually driven by a list that looks like this. And then it's implemented in exactly this way, and the only time, and then we have, if parameters are required but need to be entered by the user, we have a different syntax so that it says, okay, then we need to go to put up a dialog to get those parameters. But in principle, right, an action is either going to be able to be done without user interaction or with user interaction. So you can account for those in your JSON here. But a lot of actions maybe don't need user interaction. All right, so I'm about the end here, so I'm just going to wrap up a couple more things before I finish. So as I said, putting links in the model is sort of like putting methods on your class. When you get a piece of data back, and you can do, when Xcode gives you a ... and a little method, IntelliSense or whatever they call it. It's sort of like that. It tells you what you can do with this thing that you just got, and that if those features evolve over time, then that's great. It's self-documented. The reason I think one of the reasons we have been doing this is because in HTML the form tag is that thing, right? The form tag in HTML is a way to describe an action, what method do you use, and what are the inputs. And if the inputs are already preset, like here, value equals blue, right? That's sort of already ready to go. So JSON just doesn't, we don't really have it's like an automatic thing like that in the API JSON world, but you can certainly make them. And so this is what the equivalent looks like in that collection plus JSON standard, where it has the link. It maybe gives you a little bit of description about what the link is for. It gives you a prompt, and it gives you a what the parameters should look like, including the name and what the default value. So you can do this, right? We just haven't been doing it, but I really like this style. So let me go on here and I do one last really interesting little thing too about links that I want to show is that if you embed the links, you can actually do some interesting optimizations here, right? So I said, albums related, these are sort of sub-data collections. If the link is embedded, there's actually a link, a scheme called data URLs. And you might have seen these in CSS files where you want to embed the images or like icons and things in the CSS. Well, NSURL session and friends can process data URLs. So what you can do is, let's say for the sake of argument that the list of related artists, maybe it's an important sub-collection, but the list of related artists, maybe for this artist, is very small. Maybe it's only one, right? So having the app have to go to another resource, make another network request to get that data back, you don't really want to optimize that. You can actually embed the JSON for that list of artists right in here in this data URL and actually be processing this as a real, so then if you give this URL to NSURL session and say, get me the data, it's just going to give you back the JSON right there. So your code, again, the API, the iOS app doesn't have to change. And the server team can make these optimizations, say, hey, I'm going to put, for these very small collections, I'm going to just put the data right in. But if it's a big list of artists, maybe if there's 100 related artists, we'll then it's transparent. And so it's sort of like what CSS does with embedding images. You could even imagine that some of these images, if they were the small, like little like a profile image, is maybe only like 20K or something. You could base64 encode it and stick it right in the JSON. I haven't seen that done too much, but if you're displaying a big list of users, you want to download you don't want to wait for their profile images to come. Embed it right in as data. You can see here that you can put in image/JPEG and then base64 encode it. And that would work. And then suddenly now your list of artists or lists of whomever has the profile pictures right, boom, right in there, and it would just come up right away. So interesting kind of optimizations you can do when you're not hard coding the URLs and that kind of behavior in your app. You let the server tell you what to do. Okay, I'm about out of time, so I didn't get to caching. I apologize, but are there any questions about what we talked about so far? Yeah.
Well, my question is about caching.
Okay. Good exact slides.
So maybe you talk about this, but and I haven't done pure web in a while, but I guess it doesn't matter. What impact does SSL have on caching? Because there's like a proliferation of, well, SSL enable everything now.
Yes, right. App transport security, right? We're all going to be doing SSL. It does not directly impact the client-side caches necessarily. It will impact intermediary caches, but yeah, the server has to mark in the cache control headers. It has to mark the resources private so that it can be or public to the public, so that it can be cached by anybody if it's not a secure document, something like that, or important resource. But it used to be in the old days, browsers wouldn't cache SSL.
So that's what I remember.
But it's browsers that do that. Yeah, it's not. It's not that the NS URL cache is not hard coded to that behavior. It's just the way it's told to do what it does.
So do you know, for iOS, does it cache SSL content? Using like the shared URL cache or something?
Yeah, it should.
Does it cache encrypted or decrypted, or it doesn't really matter, I'm just wondering.
I'm not really sure. I haven't looked at it, but that's a good question.
Okay.
I'll follow up. Yeah, I'll take a look at that later and follow it. Yeah.
So pudding is what you are saying, you use that to modify existing customers. Is there a best practices for that when it comes to, like, if I've got a client, I've pulled down a resource, so I know enough about it to be able to do the code against it. Let's say the resource I get back from the server contains a bunch of information the client doesn't need.
Right.
But at some point, the client out wants to put and change some property.
Yes.
What's the standard practice there for putting? Do I need to keep around this entire payload so when I put, I'm sending everything back to something I change, or can I just do like a, change this one property, pull what you've already got on the back end, apply the change?
That's really what you can discuss that with the back end. And most of what I've seen is that if you pass up a subset and whatever is missing will get defaulted to the current state of the thing. Even though that's technically not what you're supposed to be doing, it sort of ends up being how a lot of services get implemented, because they'll fetch the object from the database or whatever, and then they'll merge in the properties and then save it. The proper way to do it, right, is the problem with that is that how do you get things removed? It can be awkward sometimes. I mean, you can null out values, right? But there is another verb that's being standardized called cache, which is that exact use case where you send up a document that's, a JSON document or some kind of document that is a list of modifications to make to the resource. So you can say, add property, remove property, things like insert property, insert value in like a list of values. And that isn't, I haven't seen that done a lot, too much, like a lot of these common APIs don't seem to implement that, but that is the more formal way of doing small operations too. That has the benefit too of if you have multiple people editing something, the put operation is supposed to fail if it gets, when you put something, you should put up, I have this version, and then that way if two people do it, one of them's going to get kicked out, right? Because it's going to be like, oh, well, your version is out of date. But on patch, you can survive that because you're explicitly specifying a delta, and it can apply the deltas from two people potentially at the same time. So, anyone else? Yeah.
Let's take the example with artists. So we have a list of artists. Each artist has a list of albums, and each album has cover picture. So to display the list of albums, I need to make get request for each album. And with slow connection, we have multiple requests, and each request takes significant time, and as a result, you have a spinning wheel running forever.
Right.
And moving this cover picture to the level up in your data is not very good from data consistency point.
Yes, potentially, right. Well, and that's true. So anytime you're embedding, if you're doing something like this optimization for embedding, it can impact the cacheability of the thing. Whatever, some of this stuff may never change, but if you include something that is likely to change, like the number of followers or something like that, then you impact the cacheability, and that means that you might have to refetch the thing over and over again or something. So with a list, with the list of albums, yes, that's a trade-off, right? To embedding it versus having to go and fetch it, and then having to go and fetch the cover documents. That's what that's where the caching can be important, because the first time you might have to do that, but if you think about it, the HTML pages for that site are doing the same thing, and it's not necessarily a problem. And then if you do the caching, once they've been downloaded, they'll be there the next time, the third time, the fourth time, the fifth time. So it's hard to get around that first problem with the image. But maybe an alternate resource like an image collection that builds a large file, lets you index into it. Is a way to do that.
Actually, practical workaround was to just download 3 screens. So current screen, screen above, and screen below at the same time.
Yeah, for like a carousel.
So it is some kind of hidden pages.
Yeah, right. Do the off screen. Yeah, do whatever's off screen forward and backwards. Yeah.
Since lunch isn't here yet, can you talk about E-tag?
I think it is here.
It is here, but you're welcome to talk.
Oh, it is.
You're certainly welcome to keep going. It's not going to get.
Here, question mark.
Yeah.
Yeah.
Sandwiches.
Yeah.
Optional change ones.
I was looking in the wrong spot.
There's
for lunch.
just
Hey, lunch isn't here, Jeff. Guys, talk.
Okay.
We're just gonna go outside and hang out.
let's do a extended conversation. E-tag. Are you sort of wondering like how do I use it or when do I use it?
Yeah, because I took advantage of all sorts of caching and like 10 years ago when I was doing this, and I never used E-tag, but I always hear people talk about it, and I haven't taken the time to read about it, so now's the time.
E-tag is, so there's kind of 2 ways to identify a resource for caching purposes. One is last modified, like the data was last modified, which is intuitive. But E-tag is essentially a way to just provide, the server can provide some kind of opaque string of data. And it's more useful because it can just, it can track at a finer granularity than a date, which may be useful. but it's essentially a way to mark, you know, you can think of it almost like a checkstone for the state of that resource. And then anytime you want to fetch it again, this will get passed up in what's called a conditional get. And just like the modified gate would have too, this will get passed up and say, you know, I have the resource with this tag. If it's not a match, if that tag is no longer a match for whatever is there now, you'll get a new copy. But otherwise, you'll get a 304 back that says, resource has been modified, what you have is fine. So you still have to make a round trip, but it's more of just rather than being a date level, it's just an opaque thing, and you probably can't even really get any information out of it.
So if you get a new thing, it'll replace the old thing as a cache.
Yes. Yes. And then going back to the put thing, if you want to update this resource with a put, you're going to send this up because this is the thing that says this is the resource of the version I got. I'm going to put some additional, I'm going to change some properties or put up a new state. And here is the tag of what I started with. And then that way the server can say, if the thing has been changed by somebody else, this won't match. And it'll give you back a specific 409 error, I think, this conflict. And then it should give you back the new state of the resource so that you can then kind of re-merge the properties or show the user, hey, this is what it looks like now. They can, choose to make any modifications and then you can resubmit it. So it's basically like a sort of a more robust way of tagging the resource with a particular version stamp or some kind of bit that is a single token. Yeah.
The way cache control is ignored in some previous iOS versions, do you happen off the top of your head
that's long, yeah, that's been fixed since at least 6. They didn't even implement URL caching in the early versions. I think they were worried about the file system impact and not wanting to spend the battery or things, hitting the file system. But now, I think that the trade-offs now of having cache content versus making Wi-Fi connections when you don't have to. The interesting thing I haven't had the time to look at yet is if you have all cache content, let's spin up the Wi-Fi antennas. If you make URL session requests that are going to return cache content, let's still spin up the Wi-Fi antenna because you're entering the URL subsystem. I don't think it does. I'm guessing it doesn't do that. I'm guessing it's smart enough to say if it's in the cache, it just gives it back to you. But assuming that's the case, and that would be a nice, and important piece of functionality because that's one of the reasons why people necessarily put things maybe in core data or in documents in flat files because they don't even want to touch the network subsystem if they're battery sensitive or if they're worried about if they're offline. But I suspect that the cache would need to spin those up, but something to look at anyway. Oh, and one thing about that too is, what if you want to force a refresh, right? This guy, put this in your request for your NSURL request. That will tell the URL cache, NSURL cache, don't give me back what's in there. Always go to the server. So that's when, if you're doing folder refresh, that's what you need. So definitely, don't use this. Don't use the old style from back in the browser days was to put a query string with like some garbage on it. That's not good. You don't really want to do that because now you're just making more copies of your resource in cache, which is just wasting disk space.
If you do that, will the response come back and be cached?
Yeah, it'll come back and cached. It'll be cached with that garbage query string.
No, I mean the first.
No. Oh, if this.
Yes.
If it's in a request header, it's only for talking to the local cache. So yeah, it'll come back and be cached.
Okay.
In the response. As long as now the server can say no cache in the response, that's how it would say don't cache. So. All right.